Okay. And then I'll go ahead and share my screen. Got it up here. Okay. So can you guys see this okay? And let me know if it's like super small. I was having issues with everything earlier. So if it's like if it looks smaller than usual, let me know. So I can at least zoom in, especially because I'm recording this. So I don't want to see the recording an hour from now and realize it's trash. Okay. Cool. So basically, let's just go over some command line stuff for now. Um, so let's go ahead and I think the first one that's going to be the most helpful is going to be CD and LS. So those are two different code, two different command prompt um, commands. So the first one is going to be CD, and this is going to stand for change directory. So I'm in my terminal right here. It's just in Visual Studio Code, but it's actually just a regular terminal. I'm also in Ubuntu, which is a Linux system, which is Unix based, similar to Mac, where Mac is going to be Unix based. So if you're on the Windows side of um, things are going to look a little bit different to you, but the concepts are going to be the same. It's just the name of the commands are going to be a little bit different. Um, and you can also run Windows subsystem for Linux if you want to, which like on Windows, where you're basically going to have like a Linux environment within your Windows system, which I find personally helpful when I run Windows. That's typically what I use. But regardless, if you stick with the command prompt, these the concepts here should be similar. So. Um, if we go ahead and do a change directory, you can see this is like the directory that I'm in. So I have a bunch of folders. I'm in my documents, that I'm in school, and then the name of this course, COP 3503, and then labs. So if I type in, actually, let's start with LS first to get bearings on where we're at. So if I type in LS and I hit enter here, basically what this is going to do is I believe it just stands for like a list, and it basically is going to list all of the files and folders I have within this folder. So you can see I have like bin build and then a bunch of different like stuff that I've done with you guys, like the memleak program I did, the pointer example, the student, um, header and source file, the linked list example I did the other week. So that's everything that's in here, right? And then if I want to change this directory, if I want to get out of this directory, I can basically do CD, and then I can tell the command line where I want to go. If I want to go back up a directory, I can do dot dot, and that's going to have me go up a directory. So I'm going to exit out of labs, and you'll see that this labs disappeared from right here because I'm no longer in the labs folder. And if I do ls again, you can see I got everything going on within this folder. And you can see labs is one of those folders that's in this directory. And I can go ahead and CD back into that if I want. And now we're back where we started. So doing CD and then typing in the name of the directory you want to go to will bring you there. And then typing ls will basically display everything that is in your current working directory. I think pwd, I believe, will basically give your full working path. This is like your current working directory, basically. So that's a good one to know. If you just type in CD, this is going to bring you all the way back home. So if I do ls, this is basically everything I have over in my home. So you can see I could CD back into documents, school, COP 3503, and then labs. Which, speaking of that, you can basically do all of this as one command. You don't need to individually type up. You don't need to individually do CD documents, CD school, CD COP 3503. You can just do it all in one, and that will work totally fine. Another cool thing, if we go back up a directory that we can see if I do ls, when doing CD or anything in the command line, you can tab to like autocomplete, which is super helpful and is going to make doing things way easier in the terminal. So I have two folders here, one called image processing and one called image processing grader. So I can actually just start typing up like image. And if I just hit the tab, you can't see me doing it, but I'm just hitting my tab key on the keyboard. When I do that, it will basically autocomplete to the string that it can match until it can't match anymore. So basically, it doesn't know if I want image processing or image processing greater. So it just basically stops right there. If I hit tab again, like double tap tab, it will basically say, okay, like I know you want me to autocomplete this, but there's two options here. Which one do you want me to complete? Right. So here I can either just add I can either just enter to go into that image processing, or I can do like the / and then start typing up whatever's inside of that folder. Or I can, if I want the other one, just type in the G because that's the next difference of the string, and I can actually just tab again, and that will bring me into the other one, and then I can just go into that directory. And then I think another thing we can do with ls, if I'm not mistaken, is do ls and then -a maybe. That didn't really give me any other information though. I think the -a command is used if you have some like hidden folders. I think sometimes when you go like into the operating system files, some of those files and folders are actually hidden because it probably does important stuff that they don't want you messing with. But if you give it the -a command, you can start seeing more stuff. It has the ... and dot. I have no idea what these mean. Some of you may know what these means, but I have no idea. So another thing you guys probably see me doing a lot is this is starting to look pretty cluttered. And let's say I wanted to kind of get rid of this off my screen. You have two options here. So one is going to be manually typing in clear. You can hit enter and that's going to go ahead and clear your screen. The other option you have is if I just do a bunch of LS's here to get the screen back. You can actually just do, and again, you can't see this, but you can do control and then just type in L, like the key L on your keyboard, and that will go ahead and clear it as well. That one's a little bit quicker, so you don't actually have to type anything. So yeah, any questions on the ls or cd command? Cool. So the next one we can go over is like making a directory within the command line. So let's go back into labs real quick. One thing to note here, I guess I should show is that this is case sensitive. So if I did labs or like lab and try to tab this lowercase, you can see it basically is auto completing all of the labs that are named with a lowercase start. So lab all in lowercase. But if I was to do that with lab uppercase, you can see that it gets the uppercase labs that I have. So all Unix systems are going to be case sensitive. I don't think that's the case for Windows. Windows kind of lets you not be as case sensitive. And even sometimes when I've been working in a Mac before, they haven't been as case sensitive as like different flavors of Linux. Linux systems have been, specifically Ubuntu is what I've worked in, are extremely case sensitive. Mac a little bit maybe less lenient sometimes, and then Windows doesn't care at all. So just good things to know, especially because I've sat here before and like typed in like lab and I want like lab 2 and I'm like tabbing a bunch and I'm like, where is it? And then I realize, oh, okay, like I capitalized that one, right? So silly mistakes like that are good to pay attention to. Let's go ahead and go into labs, and then we can basically make a folder in here. So we'll just call it like test folder. So you can do that by typing mk and then dir. This just stands for make directory. So mk is make and then dir is directory. So hopefully that's kind of intuitive to you guys. Basically make directory, and we're going to give that directory a name. So we can do like test directory. And then if we do another ls here, you can see that test directory has actually shown up within the file system. You can actually see it showed up over here as well, because this scope in Visual Studio Code is this folder right here, everything that's in here. So now we have a new folder and we can put stuff in there if we want. So we can actually cd into that. And then we can go ahead and make a file in here if we wanted. So you can do this the normal way by either like right clicking in here and then, adding a new file. There's another way that's like kind of clunky and aggressive if you want to use it. You'll have to use it over in like operating systems when you guys get there. because you are required to make new files within the operating system itself, and you aren't really in an environment that allows you to deal with a text editor. So that command is going to be nano. And what nano is it's basically just a built-in text editor into the terminal. It doesn't give you a lot of cool stuff, and it doesn't give you like formatting options or anything like that. So let's take a look at that. Let's basically make a hello world program. So basically with nano, you're just going to provide it the name of the file, right? And make sure you include the file extension or it's not going to have any. So we go ahead and enter here. This is actually going to change. It's going to look all different. It's not a new window or anything. It's just taking up your terminal. And basically, this is the blank file that we've created. So you can see the name of the file right here. And we can go ahead and just start doing everything we do in a hello world program. So we can go ahead and include IOStream. And then we can do our main. And the formatting stuff is basically what I talked about, where I hit enter here and it didn't give me another curly brace, right? So that's kind of the stuff you manually have to do. So if we go in here and we can do hello world, and this is basically all we need for this. So we can go ahead and you do Control X to close it, and then it's going to ask if you want to save, and I can hit Y to save it, and then it's saved, and then I can just hit enter, and it'll close out of that. So if I do ls, basically we can see that this is here now in this file. And if I go ahead and click down on the test directory, I can actually open up this hello world program, and it's sitting right there. And that wasn't there before. And you can just go ahead and edit those things. So I can edit this again if I wanted it. One bad thing about this that I've seen on systems, well, there's a lot of bad things about doing text editing in nano, but it doesn't have any mouse input at all. Like I can't click right here to edit, so I actually have to go use my my arrow keys. So if I did hello world 2 and I saved this, you can see that pretty much immediately took the change. So that's kind of just proving to you guys that this is actually touching this this file. So any questions about nano? That's not super important for you guys in this class, so don't super worry about it, but I just wanted to kind of show you guys that because I think it's pretty neat. And you'll end up using it later, so might as well get exposed to it now. Later down the road in CS, that is, not later in this class. All right, cool. So let's see here. Another command we can use is deleting something. So if we do ls, you can do rm and then the name of the file. I think Fox touched on this, but doing the rm command to remove something isn't going to put it in your trash. It's going to just completely delete it off your system. Okay, it's going to completely nuke it. So make sure you use this command with caution. It will just obliterate it from your machine. So we can go ahead and remove this, and then I'll show you guys my trash can, just so you can see that that was a hello world program, and it's not in here, and it's the most recent thing was 9 o'clock this morning, and it's not here. So hopefully that proves to you that it is just completely gone from my system. If we do ls again, it's not here. So let's go ahead and let me actually copy this while I can, and then we'll go ahead and make a new file here, because now I want to show you basically putting it back so I can show you how to delete folders. So with folders, I CD'd back out, so we're in the labs, and I want to delete just the entire test directory folder, right? So if this folder was empty, we could just call remove test directory, okay? And that would completely delete it perfectly fine. Most of the time, your folders are going to actually have something in it, right? That's the whole purpose of folders. It's basically going to store stuff. If I try to do this, it's basically going to yell at me and say, we can't do this. This is a directory, right? So the fix to this is you can just do rm and then -r, and then you can do test directory. And what that -r stands for is recursive. So it's going to recursively go through this directory and delete everything in it, starting with, the deepest folder path recursion call, and then propagate upwards. So if I do this now, test directory is going to be completely gone, right? And this follows the same principles as RM. It's going to completely wax everything. So definitely be super careful with this because I mean, using that recursive call means it's going to go in there and delete everything. So you really want to make sure that that folder is no longer needed, and everything that you do want from that folder is either out of the folder, or you should go in and delete specific things in the folder. So just use those with caution. Any questions about make directory or remove? All right, cool. So there's one more, which is move. So let's say I wanted to move main out of here. Main, this is just an executable. So I should also let you guys know that there's different colors in here because everything in this kind of like dark bluish or light bluish rather color is just a normal file. And then everything in this neon green is an executable, and then purple are folders. So that's just something that this machine is doing. And I think you can probably mess with terminal settings to have it color code different things as you want. I didn't choose any of these. I chose the whole terminal color, but I didn't choose those individual colors. But I'm sure there's a way to go in and do that. So if we want to move this main somewhere else, let's say we want to move it up a directory, you can just type in MV, which is going to stand for move, and then give it the name of the file you want to move, and then you're going to give it the location of the file you want to move it, the location of the folder or directory you want to move it to. So to move it up, you can just do ... because the ... stands for the folder, your parent folder, right? That's why we do CD and then ... to go to the parent. This is the same concept. So if I do that, we do ls again, you're going to see main is gone from here. And if we go up a directory and do ls, we can see that it's up here in the directory. If we wanted to move it back, we can do main and then do labs. And then if we ls, it's gone from here. We can cd into labs and then do ls, and we can see that main is back. So hopefully that's pretty intuitive. It's just a way to move things as opposed to copying and pasting, especially if it's like a massive folder. You can just call it like move command, and as opposed to going in there and going through your file system. So that, of course, is a personal preference. Okay, so I think that's pretty much all of the like terminal command prompt commands. Again, in Windows are going to be a little different. The one I know offhand, ls is going to be dir in Windows, and I don't think that's going to work here. Oh, it does. Cool. So it looks like that actually works in Unix as well, is doing dir. I think that is the only option you have in Windows, if I recall correctly. Most of the time you see ls, mainly because it's like one letter shorter, so it's easier to type. That's going to end up doing the same thing. Oh, it looks like dir does not color code things for you, though, at least on my machine. So I definitely want to stick with ls. A couple other things that I guess I forgot to mention is you can cycle through your commands using the up and down arrows. So I can hit my up arrow, and this is actually just going to cycle through all of my commands. So you can hold that down, hold it up, and cycle through. And usually that's pretty helpful if you have one or two commands up that were super long. Like, of course, ls, you don't really need to cycle through to get that because it's 2 letters. But let's say there's a pretty long command that you had that you don't feel like typing up again. You can basically just cycle up to it, and then you can just hit enter, and it'll run that command. Or if it's a super long command and you don't remember what that command started with, or it's way up in your history, you can actually do a couple things. One is you can actually just type in history, and if you hit enter, this will actually bring up your history, and it'll bring up like 1,000 things. So like you can see this was I think running all the memleak stuff I did last week. Here's a couple like git commands, installing a bunch of stuff, more running Valgrind with the memleak I did a couple weeks ago. So you can see this goes back pretty far because I think this was like 2 or 3 weeks ago. And I used my computer a decent bit. So that's pretty impressive. The other thing you can do is if you don't feel like scrolling through the history, you can do a reverse search and do Control and then R, so the R on your keyboard, and you can basically type in what you think the command started with. So let's say I was running code and I remembered, oh, it started with G++. Then your options will show up here. And then you can just go ahead and run that. So let me show that again. This is super far up there. Let me just go ahead and delete this. So G++. And then there should be a way to cycle through these, but maybe not. So it will basically just keep matching the search until, so like I've run other G++ commands with doing like main first. So you can see how that search changes. So like for instance, this is what I'm actually searching. I should probably make this clear. This is what I'm actually typing on my keyboard. And then these are the options it's giving me. So if I started typing whoops, try it again. G++. So you can see how what it's providing me is G++ main.cpp. If I started typing what I knew I typed earlier, which started with a dash, it will change basically what it's providing me because it's just matching those strings, right? So hopefully that makes sense. And that can be pretty helpful when you remember the first part of the command and you can't remember the last. I use that quite often when it's a long command, and I did it, a month ago or whenever it was. So. Another thing, I guess, that I just did and I didn't explain to my other lab, but you can do Control C to basically kill whatever is running in the terminal. So if you ever run code in here that has an infinite loop, you can basically just do Control C. And I think you guys probably saw that with the mem leak when I was running up my RAM. If you guys showed up for that one, that's how I killed that program as well. I just spammed it with Control C to stop that process. So that one is super helpful to know. Any questions about anything I've done? That's probably all I got for that. Next, I'm going to go over some command, like running code in the terminal. But any questions? All right, cool. Okay, so the next thing we can do is actually run some code. You guys have been seeing me do this all semester because this is pretty much the only place that I run code in. But I will explain like what the different things I'm typing up now are. So it doesn't really matter what this code is doing. You've seen different iterations of it before, but I basically just want to run this main.cpp, which is running like instances of the student class. Okay, so what we can do here is basically type in G++. So this is going to be the name of the compiler that we're using. Hopefully you guys are familiar that we're using G++ as a compiler. So this is just the command name, right, is G++. Everything we're going to type in after that is either an argument or a flag. Okay, so I'll type it up the way that I think about it, the way I personally walk through it, and then I can go ahead and type it up the way I think Fox does in his lectures. Neither one is right or wrong. It's a personal preference. It's probably just comes down to the way you think about reading that line and what it's doing. But just to be clear, it's not like one is better than the other. It's just whatever makes sense to you or your team if you guys have some sort of standard. So this is the way I think about it. So it's going to be G++ and we want to run main. So we type in the name of the source file, which is going to be main. And then we are going to give it the output name we want this file to be executed down to. So you have your source files that you write the code in, but then as you guys know, they go through the compilation process and they're going to turn into an executable. So here we're giving our executable a name, right? So what you guys have probably seen me do is I basically just name this whatever the name of the file I'm running, right? So we'll just go ahead and name this main. So this -o is the output flag. So -o, and then -o is going to take in an argument immediately to its right. That is going to be the name of the executable. The last flag we're going to give this is the standard flag. So all flags, I didn't really explain this. All flags are going to start with the dash. So anytime, like when I did ls-a, that's a flag. That's an option I can run with the ls command. So that's exactly what these are. So we're going to run it with the standard flag, and we're going to set the standard that we're running with. So that's going to be std, and then equals C++11. So this is just one iteration of the C++ language that came out in 2011. This is just the year name. So you can do, I think 17 is one, if I'm not mistaken, and then maybe 19. But I think a relatively common one is just 11. I'm not super sure why. I think it's just what we've been doing for a while. So yeah, and that's pretty much all you need to do to compile it. So specifically what's happening right here will give me an error, and I'll explain that in a second. So if I go ahead and run this, it will basically give me a linker error. The reason is because you can't just compile the file you need to run. You need to compile all of the source files included in what you are trying to run. So if you guys are using IDEs, that's done for you. Your IDEs, if I'm not mistaken, basically make some type of make file for you, and they're going to compile all the source files needed. And I think if you guys show up to my labs and have paid attention, I've made this mistake a few times where I don't give it all of the file names, right? So to actually run main.cpp, we need the student header file, but you don't compile header files, but we're going to compile the source file that goes along with it, right? So we also need to just compile the student as well. So this is perfectly legal. You can have G++ and then as many files as you need. And it will take in all of those arguments. And then we can go ahead and just hit enter. And now basically no news is going to be good news. Meaning if it doesn't spit anything back out at us, that means the compilation was completely successful. You could still have runtime errors, you can still have logic errors, but the compilation process was fine. Any questions on that line, what we typed up there? All right, cool. So to run it, you have to actually hit the dot and then the /. This is a couple reasons. One, it's if we do ls here, main is the name of my executable. It actually won't recognize main as an executable. It will be like, you know, do you want to install things that are named this? It doesn't think main is a command. So we actually have to do a dot / and then type in main. The other part of this, I think you'll learn it in OS. And if I'm not mistaken, it's for protective purposes, where it makes sure that you're actually running this file in this location. Meaning if there is another file named main on your computer, it will make sure it runs this one specifically, which is why it doesn't just have main as like a global scope, right? This right here basically scopes it down to this particular folder. So if someone had, you know, put a malicious program on your machine that's called main, it won't accidentally run that in the global space, right? Because if you think about it, all these commands here are like in the global space, like ls, cd, like it's not just understood in one directory, right? So I think that's pretty much the reason you need that. So you do the dot / and then if we hit this, it will basically run. Again, it doesn't matter too much what this is doing, but this is actually what the output is going to look like in the terminal. One thing I want to make clear too that a lot of people look over is I'll basically change this back to how I had it before in the lab. But if you'll see on 40, I'm going to basically change something about this file and then run it again, and let's see what happens. So this should actually be doing like robert.getAge, I think. Yeah. So if we go ahead and run this again, what you're going to see is that it actually hasn't changed at all, right? This should be what I changed here should actually be outputting some kind of age. The reason is we didn't recompile it. Okay, we're just running that same exact executable. So we actually need to go over here and recompile. It's going to overwrite that file name main. It's just going to completely overwrite it, and we can run this again, and we can see that Robert's age is now 23, right? So we actually the change we made actually stuck. When people first get into running things in the terminal or the command line, they oftentimes this kills them because they will keep changing their code, and it seems like nothing is changing, nothing's working, and it's because they've forgotten to recompile every time, which is super frustrating. So So I told you guys that I prefer to type it in this way. And we can go over, I think, how Fox does it, which is basically he does. This is from what I've seen on his lecture slides. At least it's G++, and then I think he immediately does the output flag, which you'll have to give main, and then you can type in main.cpp and then student.cpp, or whatever your file names are, and then equals C++11. So hopefully showing that compiled fine proves to you guys that it's okay to flip these orders around. We could even do like the standard 11 flag first. Basically, all it has to do with is making sure that you have whatever the flag is expecting is to the right of it, right? What you can't do is something like this, where I do -o and then main.cpp and then student.cpp and then do like main and then std equals C++11. So this will basically fail. It gives you some gross errors, and I think the reason is it's because it's trying to name the output file this, and then it's trying to compile this, and it's trying to compile main, and it can't compile main because main is an executable, not a source file, right? So hopefully that makes sense. The only these are fine, these three. You just have to make sure that whatever's to the right of the flag is what that flag expects. So yeah. Any questions on that? All right. So we can go over some stuff about make files. So let me go ahead and just make a make file in this scope. I already have one, but I kind of put it in some folders to show some other stuff. Let's go ahead and just make a new one. So when you do a make file, it's basically going to just be make file, no txt extension, nothing. You'll need a make file for project 2, which obviously you guys are working on project 1, so you don't really care about that too much right now. But a lot of students, when first making their make file, will complain that it's not working, and we go check the extension, it's got txt on it. So just make sure that it doesn't have any extension, because that's a pretty common problem. I think it's just, unfortunately, a lot of especially in Windows, when you don't give something an extension, it like defaults to a txt, which is super frustrating. So you actually have to go in there and manually delete that extension. But we won't have that problem here. So what you'll see is it can actually recognize that this is a make file. We get a nice little symbol here. So we can give this what's called a rule. You can literally name this rule, or in this case, let's call it build, because that's what we want to do, right? We want to compile or build this executable. So you can basically go down in the new line, use tabs, not spaces. Make files do not play nice with spaces. And what we can do here is, actually, now that you guys know what this is doing, you can just literally copy this. See if it actually pastes. Did I copy that correctly? Okay, cool. You can just paste that in there. And this rule, like this build, will be the first thing that runs when we type in the keyword make. Okay. So if we do ls, we'll just make sure that our make file is here, because wherever you run the keyword make has to be in the scope of where the make file is. Otherwise, it's not going to find a make file, and it's going to yell at you, right? So if we type in make, it will go ahead and print out what it is running. All right. So usually this happens. I think I messed something up. And let's remove main real quick and do this again. Okay, let's name it maybe something else. I have another make file floating around. I don't know if that's messing with it. Let's go ahead and do this. Okay, main.cpp. No file exists. Oh, you know what? I think I just nuked my main. Maybe? No? Where did it go? Okay. So it looks like... All right. Yeah, it looks like my main is gone, which is super cool. So yeah, I must have deleted that. Luckily, I can just copy this real quick. So I guess be careful with the remove. I'd have to look back on what I did, but it looks like it may have like removed main, but I can go ahead and copy this. I may have just accidentally deleted it somewhere. But let's go ahead and make a new file and just call that main. Okay, let's try this again. Make file, and we'll call this build again. This worked earlier, so not sure what I'm doing wrong this time. Make build is up to date. Okay, that's cool, but I actually want this to run. There we go. Okay, I guess you can't call it build. Not sure why, because I'm pretty sure in my other make file, I have it called build. So build might be like a very specific keyword that I'm messing up here. And because I have another make file made build, it might not like that I'm naming another one build. That's my only guess right now. But we called it run. We called it something different. And this is basically what's going to happen. It's going to run this code, and you can see when I typed in make, it actually ran that piece of code, right? And then we can do ls, and we can actually see we have an executable here. So let me do that again. So if I go ahead and remove main and do ls, you can see that the main isn't here. And if I run make and then do the ls, that executable is actually going to show up. So this right here was before the make, and then this is after. So basically this make file will run that command for you. So even if you're doing like a pretty simple project and you're tired of typing in, assuming you're not using an IDE and just hitting a run button, and you're tired of typing in something like this, you can basically just make a quick make file for yourself, which is pretty neat. But obviously these make files become way more helpful when you're using them for like really large scale projects where you have to really run a lot of stuff in a lot of code, and you got a lot of working paths and folders. So let's go ahead and take a look at this. I have another make file here that I did earlier, which basically is doing a couple different things. So this build folder, or excuse me, this build rule is basically going to actually build it, and then run is going to actually run the program itself. The other thing I did, which is common, which is something that you guys don't have to do for Project 2, but they'll actually make bin directories for output executables. So things that are actually executable, they'll send them to a bin directory. And this is helpful, especially for like if you're using Git, and you can basically add the entire bin folder to your git ignore file. If you guys are familiar with that at all, basically it's when you push it up to Git, you can ignore that there have been any changes inside the bin folder. So separating and organizing them like this is helpful for source control. If you guys are just making your own project, kind of overkill, not super necessary, but it is something that's common. So what we've done here is the same command. The only difference is that we are actually setting as the output files, this is the output file. We are sending it to the bin. So we're going up a directory because the make file is actually in our build folder. So we have to exit out of the build folder, and then we need to go into the bin folder and then find main. And by find main, I mean create main in here, right? Because it doesn't exist in here yet. And then the executables, what we're actually running, again, we have to leave the build directory, and then they're right here in that directory. So remember, those ... means you're going to go up a parent directory. And then the same thing with run. We have to go out of this build directory and then go into the bin directory to actually run what's in there. So everything in C++ is kind of nitty gritty, and you have to really make sure that you're telling your files and paths where things are located. Okay, it's not like Java where it can just see things. You're really going to have to point it in the right direction. So let's go ahead and see if this one will work at least. So we could type in, need to go to the build folder. Again, we have to be in the location of the make file we're trying to run. So I can just run make, and it will actually do that. And then if we click on bin here, you can see that there's actually a output file in there. Also, if you click on the output file, we can look at it, and it just looks like trash. Just a bunch of hieroglyphics and gibberish. So kind kind of neat, but also kind of nothing to see here. So, and then what we can do is type in make, and then you can basically type in run. So you're going to give it the next rule that you have in there, and that will actually run the command. So this is actually main being ran, and this is again helpful on large scale projects. Also, excuse me. Obviously, something like this is kind of trivial, but it's cool to know all these skills and techniques. For project 2, you guys are basically just going to have a make file that looks like this. It doesn't have to do anything super fancy. Another common one that is made is clean, where this can basically remove what's in the bin. Again, so what you're seeing is a lot of these make file, like what's in the make file, is actually stuff you would just do in the terminal, but you're automating it to do it for you, right? So that's why it's helpful to learn terminal commands, and then you can go ahead and learn them and apply those in the make file, right? So if we do we can basically, when I run this make clean command, you're going to basically see that main just disappeared right there. So it's no longer in the bin. If I did make, just make, so here, I didn't really state it, but maybe it's obvious that if you just run make with nothing, it's just going to pick this very first rule out, basically. But you can also explicitly give it the rule to do, and then you can do, make run, and then make clean. Sometimes make clean will actually, you can copy this down, and you can have make clean actually compile it for you, or it won't, because did I delete it? Is it there? Oh, I already deleted it. That's why. So there's other checks you can do in make clean that like check if this exists. I don't really know what those look like, because make file syntax it's not as far as I know, it's not as simple as just putting like an if statement in there. You actually have to like do some file checks to make sure that it's actually there, because see, we got an error here when I try to do make clean. I try to remove this, but it can't be, because no file or directory exists. What I was trying to show is if we do make build, if it does exist, you can do a make clean. And what this will do is it will remove the old binary file, and it will basically make a new one. So you kind of, do 2 steps in one, where you make sure that you're deleting the old one, and then you create a new one. Of course, just building a new one with the same name is just going to overwrite the file place anyway, so that's not super necessary, but you could do that if you wanted to. Let's see if I can do this off the cuff. I didn't do this earlier, but we could do like if we wanted to send output, there's a command called echo, where you can basically echo something, meaning you can send it to like a text file. So we could do that in the make file, where we actually like run the code and just send the output to a text file if we wanted to, and see what that does. Echo. If you guys haven't figured out yet, half of programming is just looking stuff up. Let's see here. Again, kind of the stuff I'm showing you guys right now isn't super needed for this class. You won't need to do something like I'm showing you. It's just kind of, I personally think it's kind of neat, if I can figure it out. I've done something like this before, but I can't remember it right now. And some of you guys may have done this before as well. Let's see here. You can actually just do, it looks like you can just use like a C out is. So let's see what this, first let's do this. Let's do, where are we? Usually it's more helpful to like test things like outside of the make file, because sometimes make files can have really weird errors. So we can do main, and then we can do what's it look like? My file.txt. And then if we look at my file.txt, whoops, yeah, basically all the output was sent to that file. So this, it looks like the actual errors don't get outputted to it, but the actual output does. So that's pretty neat. So you could do something like that literally right in here, where you do my file.txt, and you need to give this, unless you want it in the build directory, you probably want it in like in the bin directory. Do something like that. And then we can go into build, and then we can type in make sure it's built, and then make run. And it yelled at me. Okay, so we got to go outside of the directory first, and then we can do that. All right, cool. So then you can see in our bin directory, we actually have this this file. I've done something like this within a make file. Just to bring it to like real world, I've done something like this in a make file, like out in the industry, to basically compute how long something was taking in our system, where you can basically just send the output from the file into another file, just to record basically how long the program took, which is pretty neat. So if you guys did like the extra credit for uh, Lab6, you could have done something like that. Instead of having it just reading in the terminal, you can basically output that to like a text file, and basically have that persistent in your machine. So it's cool stuff like that. Obviously, you don't need a make file for that. You can just do that in the, because I did that in the terminal, but doing it in here means you don't have to type it up every time, or remember it, or excuse me, or not remember to have to go look it up. You'll just have it here, right? So if all of that was weird to you, don't worry about it. Really, the only thing you need to know is this make file here. I was just showing you stuff that I personally think is cool and interesting. So that's pretty much all I had for you guys. I'm more than happy to stick around for going over quizzes or anything like that. So you guys have a good one. Have a good week. Good luck on everything you got going on.